alleles on HIV disease outcomes in Mexico and Central America?
Good afternoon, everyone. It is well established that human leukocyte antigen influence the rate of HIV disease progression. The most consistent associations have been reported for HLA-B alleles. Of this, HLA-B35 has been associated with its accelerated progression with the most deleterious effects linked to a group of HLAs called HLA-B-PX. These PX alleles differs as a few as one amino acid from other B35 alleles, refers as HLA-B35PY alleles that show a somewhat reduced rates of disease progression. PX and PY alleles have been differentiated on the basis of their F-pocket epitope anchor preference, with PX only allowing for tyrosine in this position, while PX alleles can bind or accommodate a range of other residues. Both groups bind proline in position 2. Last year, we aimed to study the association of B35 alleles with viral control in an untreated cohort of almost 1,000 HIV clade B infected individuals from Mexico, and tried to relate this difference to non-PX and PY grouping. Contrary to previous studies, we have found no impact on viral load between these B35, PX, and PY. However, we observed difference in HIV disease outcome associated with specific B35 alleles. For the present study, we increased the Mexican cohort with almost 500 individuals to a total of 1,474 individuals. We also recruited 1,400 individuals from 5 out of 7 countries of Central America, including Guatemala, with more than 400 individuals, Belize with 100 individuals, Honduras with 340 individuals, Nicaragua with 243, and Panama with almost 300 individuals. The selected cohort for this study is exceptionally well suited to study B35 subtypes, as it is expressed in 27% of the individuals, including a number of unstudied B35 alleles. We have found 27 different B35 alleles, 10 with an N greater than 10. In the graph, you can see this alleles graph. We compared the B35 allelic frequencies between Mexico and Central America. B35, 14, 16, and 17 were significantly more frequent in Mexico and Central America, and B35, 01, 20, and 43 were more frequent in Central America than Mexico. Of the expressed B35 alleles in this cohort, B35, 01, and 08 has been previously classified as B35PY, and B35, 03, and PX as PX. The remainder of these B35 alleles have been associated, has been expressed only in Latin American individuals, and has been poorly described before, and their HLA binding motifs are unknown. So, when comparing viral loads between B35 positive and negative individuals, all but 3 showed median viral load above the population median. Differences were statistically significant for the most frequent allele and previously classified as PY, B3501, and for the less frequent and previously classified as PX, B3502. The Amerindian allele, B3512, that is the second most frequent B35 in the cohort and not previously characterized in the PX-PY grouping, was associated with higher viral load. Although not statistically significant, B3508 had a modest protective effect on the disease outcome. Exists previous evidence of HLA additive detrimental effect. To investigate this effect, we compare viral loads of individuals co-expressing B35 alleles, we have found significant difference in variant control of individuals co-expressing 2 B35 alleles and 1 B35 allele, suggesting that individuals positive for 2 any B35 alleles are in disadvantage in comparison with individuals positive for only B35. To test whether this effect is due to particular B35 alleles, we compare viral loads of individuals homozygous versus heterozygous of the most frequent B35 alleles in our cohort, and compare that with the B35 negatives. We have found no significant difference between homozygous versus heterozygous of B35 individuals, but we do found significant difference between plasma viral load of homozygous and heterozygous positive of B3512 and the viral load of B35 negative individuals. This is a novel Amerindian allele associated with higher viral load. When HLA-B35 alleles were grouped into PX and PY and unclassified B35 alleles, all 3 groups show higher viral load than HLA-B35 negative individuals. The viral loads of B35 PY and B35 unclassified individuals were significantly higher than the negatives. We observed no significant impact on median viral load between PX and PY groups. To test whether adding further putative PX and PY alleles will yield stronger differences between allele groups, we classify B35 alleles on the basis of the polymorphism in the HLA-F pocket. Individuals expressing B35 with asparagine and position 114 and tyrosine or phenylalanine at position 116 were classified as B35PX, as those with aspartic acid in position 114 and serine in position 116 were classified as B35PY. With the new categories, we still not observe significant impact on median plasma viral load between PX and PY. Finally, we correlated the allelic frequency and the median viral load of B35 alleles in Mexico and Central America and in every country to look for frequency-dependent effect, because we have the hypothesis that B3501 that has been previously associated with risk it's fixating and mutations driven by his higher frequency. But unfortunately, now that we updated our database, no correlation were found. To summarize, B3501, B3502, and B3512, which the last one not considered disease-susceptible allele, were associated with higher plasma viral loads. We observed B35 additive detrimental effect and no homozygous disadvantage for specific B35s. Our data indicate that the classification of HLA-B subtypes into PX and PY groups does not satisfactorily explain difference in median viral load. These results challenge the B35 PX PY hypothesis, indicating that PY also can be disease susceptible, and also that difference exists in disease association within the groups. Also, the previous observation that the negative effect of B35 allelic groups is due to PX alleles is not supported by this data. We conclude that the detrimental effect of B35 is unlikely to be related exclusive to PX and PY grouping. I would like to acknowledge my mentors, Gustavo Reyes Cerón and Santiago Ávila Ríos, our collaborators at CIENI, Daniela Garrido, Selma Alma, Maribel Soto, Tania Escamilla, and Claudia Garcia and Talia Garcia. All the clinical lab at CIENI, informatics staff, administrative staff, and the CIENI medical team, or all of our collaborators from Central America, and all the Mexican physicians that recruited HIV patients. We also like to acknowledge our founders, the Mexican government, Comisión de Equidad y Género de la H Cámara de Diputados, and the National Council of Science and Technology, CONACYT. Thank you.
Questions?
That's an interesting conclusion. I was wondering, over here,
Okay.
I was wondering if you looked at haplotypes, especially since B35 is an allele with CW4, so did you look at what the other C allele might be with these different
Yes.
B35 alleles?
There are very strong linkage disequilibrium between B35 and CO4, but because CO4 is always present with B35 alleles, it's not possible to segregate or to convolute the association between those alleles.
Did you see any different CW4 subtypes?
Between B35 alleles?
In your population?
No, most of them, there are CO401 and O2. And in Central America, we also have O4 and O8, but in very low frequency.